Hello and welcome to the 10th video in this tutorial series on how to make a planet defense game. In this tutorial we will be adding a Starfield to the background of the game, which will make the game look much more pleasant and realistic. So the first thing we will be doing is adding a Starfield to our game, Starfield class to our game, sorry. And one thing that Flixel does excellently is breaks bulkier code out of the main library and puts it into a different library called Flixel add-ons. So just like there's the Flixel library, there's the Flixel add-ons, which adds on certain classes to the Flixel library, which you may use. So to import this extra library, open this file called project.xml. This is not in your source folder, it will just be in your general planet defense folder. And scroll down and you'll see here hexlib name equals Flixel, and that basically includes the Flixel code. Now we want to also include the add-on code, so duplicate that line and after Flixel just put dash add-on, just like that, add-on. Sorry. Now you may not actually have this library installed on your computer, so to install this library just open up a terminal and write hexlib install Flixel-add-ons, just like that, and click enter. And I already have it installed, so it's not going to let me install it again. However, for you, just let that run through the installation and put that code there as I have done. Now in your code you can use any of the code that's been written in Flixel add-ons. One such piece of code is a Starfield. Now this Starfield we have to modify and extend because by default all of the stars scroll to the left of the screen. However, we want it to scroll in the opposite direction of the player, so it seems like they're still when the player is not moving, but they move when the player is moving. So let me just show you what I mean by that. So create a new file. Let's call this stars.hx and include this in your source folder. Now, as we have done before, just write package semicolon. I can type. And then let's import some stuff. So we need FlixG, so import flixel.flixg. We need FlixColor. So import flixel.util.flixcolor. We need FlixRandom to generate random numbers. So we need to import flixel.util.flixRandom. We need to also import something that you won't have seen yet, and that's Flixel.addons. So this contains all of the code that we just imported. It's important that you install it through your terminal and change your project.xml file and save that if you want this to work properly. So open up your stars file again and import flixel.addons.display.flex Starfield. Now you might say, as I was typing then, it's got a bunch of display classes such as skewed sprite, zoom camera, and grid overlay. There's quite a few there, but we just need Starfield, because this is the class we will be extending to make our own custom Starfield. So write class stars extends, because we will be changing the code put out by a class called FlixStarfield2D. So here we can just say import extends flixel.addons.display.flexStarfield .2D, just like that. And that is basically a 2D Starfield which we are putting in our background. So basically this Starfield will detect the changes in the camera position from the previous frame, so the previous update, and then it will push all of the stars in the opposite direction as for the player to appear like he's passing the stars. It will make more sense when we have a look at the finished game. So write public function new, and the first argument is an x position, so we can just put x there, and then the next argument is the y position. The next argument is the width of this Starfield on the screen, so that will be set to obviously our program's width, flixg.width, and the height of our Starfield. And the final argument we will have will be the amount of stars that we have in our Starfield. So just put star amount here. Then opening and closing curly brackets. And then, as we've done so many times in the past, just write super, which basically tells Flex Starfield 2D about this information. And then we can pass it in x, y, width, height, and star amount, if my computer's able to keep up, just like that. Now what we need to do is create some more variables. So up the top of your class, outside the new method, let's create 2 more variables, and I was talking about these just before we created our new method. One will be called lastCamX, like that, and this will be of a type float, so colon float, and this will have an initial value of 0. And then we can duplicate this line and change it to lastCamY. So we've made 2 variables called lastCamX and lastCamY. These variables will store the position of the camera the previous frame, because of course this program's updating its frame 60 times a second, so we're going to store the position of the camera at last frame. So here in our new method, because of course this new method will be called when we create the Starfield, lastCamX equals flexg.camera.scroll.x, and then we can duplicate this to store y. Now what is this doing? Well, basically what this is doing is it's storing the position of the camera when we create this Starfield. So now let's make it so that it has a scroll factor of 0. So just put scroll factor dot set, and then don't give it any arguments, but to default to 0. Now basically what this will do is it will make sure that our Starfield, which is actually just a big sprite of dots in the background, doesn't move, because if it moved it would appear like there was an image of stars in the background, and we don't want that. So make sure you have that there. And then below it, there's a variable that's inside Flex Starfield 2D, and we want to change that, and it's star velocity offset. So let's just set this, and this takes 2 arguments, x and y, and of course we can just set that to be nothing, like we did with scroll factor, if we don't want any star movement. But let's just say for now 3 should be the value, so 3 on the x-axis and 3 on the y, and put a semicolon there. Now we are going to change this. I just want to demonstrate what this variable does. Basically it stores how much these stars are moving. So go to your playstate file, and there's a little bit of code we have to add. So scroll down to your create method here, and up the very top below bullet group and turret group we will create a Starfield. So here let's just put there Starfield equals new stars. Now the first argument it takes is of course the x position, so let's just set that to be 0. The next argument is the y position, so let's set that to be 0. The next argument is the width, so we can just set that to be flexg.width. Next argument is the height, flexg.height. And next we want to input how many stars we want on the screen at once. So I'm just going to set this to be 100 stars. Now let's add this to our screen. So add Starfield. And let's see what we have done. So write lime test Nico. Type not found stars in playstate 47. Okay, let's try and fix that. Oh, right, I just made a mistake. I named this file star, not stars. Easy fix. Now let's try it. Right, there you go. And you might be able to see in the background, we have got stars that move to the bottom right hand side at a very, very fast rate. So, to fix this, we need to change 3, which is saying, alright, move 3 pixels down and 3 pixels to the right. We need to change that to be the distance between the position of the camera last frame and the position of the camera this frame. So let's actually just remove 3, 3 from that, and that will remove the default value of 3, 0, which is moving stars to the right, and we would just set that to be 0, so the stars are frozen. If you were to execute this at the moment, the stars wouldn't move. So let's fix that, of course, and make it so the stars do move in the opposite direction of the player's movement. So, of course, we need to override the update method to get code that runs every frame. And so just put here override public function update. Like that. And then here we just want to say star velocity offset dot set. And basically what we want to do is we want to say flex g dot camera, so the active camera dot scroll. So the camera's position, scroll is basically where the camera is, but of course the actual position of this camera is 0, 0. The camera never moves, but scroll does move. That's basically what scroll is. It's the position of the camera in the world. So then we can just say scroll dot x minus the position of the camera on the x-axis last frame. So flexg.camera.scrollx minus last cam x. Now this is in the wrong direction. This whole piece of code will move in the direction that the player moved, but we want the stars to move in the opposite direction so it looks right. So add extra brackets around that. Let's just say minus. You might have also been able to flip this around. So it's last cam x minus this. Yeah, let's try that actually. Last cam x minus that. I was going to just put minus, but this might be easier. So actually just flip that around to be last cam x minus the current position of the camera. And then let's divide that by maybe 15. Because otherwise the stars move at the same pace as the player, and we want it to be far, far slower because they're in the background, of course. Now let's actually copy all of this code and put it as the y argument. So change x to y, just like that, and put a semicolon. Now, of course, we need to, because this is the update method, we need to call super.update. Now, there's actually a reason why I have I put super.update after this piece of code here, and that's because basically super.update moves the stars, but before relative to this star velocity offset, but we need to set the offset before it moves it in the offset. If you don't fully understand why we need that order, it doesn't matter whatsoever, just put it like that. Now, of course, last cam x and last cam y at the moment are not changing. So at the end of our update method, the very end, that's important, you put last cam x equals where it is now, so where the camera is now, the flexg.camera.scroll.x, and duplicate that for y. Just like that. Now if we run our game, hopefully the stars should move properly. And there we go, we have got stars that move properly and relative to the player. Now you might be able to understand why we want it to move in the opposite direction to the player. See, when I move this way, the stars are moving in the opposite direction. And this is exactly what we want. Now if you want the stars to move faster or slower, you can just change that value where I put divide by 15. But I think that I'm fairly happy with Starfield at the moment at this speed. So in future episodes, what we're going to be doing is polishing it up by adding some sound effects. Now I know I said that I'd do this episode, however it turned out that this episode was long enough already, but I promise that in future episodes we'll cover things like getting rid of these black borders and adding sound effects. So thank you very, very much for watching, and if you need any help with this episode, you can contact me on Twitter with @5mixer. Thanks a lot.